Let's talk trend lines and linear models. Here we see a graph. It shows the use of a trend line. A trend line is the line that is closest to all the data points on a scatter plot. This equation gives the line of best fit, which then shows the equation of the trend line. So basically, we have a bunch of dots on a graph. We figure out what line is the absolute closest to everything. It kind of shuts through the middle, and that is our trend line. We then use this trend line to come up with an equation, and then that equation we can play with. Okay, great. What is the slope of the linear model, and what does this mean? All right, well, I love this for us. So remember that slope is the y's, change in y's over the change in x's. So my slope is negative 4.6. If I want to make that a fraction, I can just put it over 1. We know it's negative, graph goes down. Now, what do the y's stand for? Well, the y-axis is overall course score. Okay. The x's represent the number of absences. So the slope means that the overall course score decreases, I know it's decreased because it's a negative, decreases 4.6 points for every absence. Right, because it's one absence. So for every absence, your overall score goes down. That's based off of this data. Okay, so what course grade does the model predict for students who missed 0 classes? Well, 0 classes would mean x equals 0, right? So if you think about this, but if we look at our equation here and say, well, if x equals 0, negative 4.6 times 0 plus 81.2, anything times 0 is just 0. So we would expect someone in this particular class, if they didn't miss any classes, we would predict a score of 81.2. Because obviously there's more that goes into a course grade than just attending class, but that's part of it. Number 3, use the equation to predict the course grade for students who missed 5 classes. So we can see that on the graph, like approximately where that is, but we know that means x equals 5. So again, I'm using the equation y equals negative 4.6x plus 81.2, and I'm substituting in 5 for x because x represents the number of missed classes. So what is negative 4.6 times 5? Well, that is negative 23. So I have y equals negative 23 plus 81.2. We would expect someone who misses 5 classes to score a 58.2 as an overall course grade. Number 4, the actual data point for 5 missed classes is 561. How does this model's value compare? Okay, so this that they gave us is the actual. The estimate that we just found on the previous page was 558.2. Let's just round that to 58, just for easy math, okay? We estimate 58 for a score, and the actual is 61. So I could say the actual grade is 3 points higher, absolute change, right? Because 61 minus 58 is 3. And then if I take 3 and I divide by 58, I would say, or it's 4.8%. Oh, hold on a second. I used 58.2 in my notes. So let me change that to, it would be roughly 5.2% higher than the estimate. If you actually used the 58.2 just for fun, you would say the actual is 2.8 points higher, or 4.8%. Okay, so that's kind of whether you round it to 58 or use 58.2, but that's the idea, is using absolute and or relative change. Now here we talk about scope, So we're going to talk about scope of the model. Now, the scope of the model refers to the range of values of the independent or the X variable. So when you think about estimating with a trend line, you can't necessarily just estimate to the ends of the earth. It doesn't, or the ends of time. It doesn't make sense. So we want to just kind of stay pretty close because things are going to change. When you think about like a real life example of this is companies that predict profits for the next quarter. You don't hear Amazon coming out and saying, well, pretty sure in the year 2030, we're going to make $30 million a month. You don't hear them say things like that because there's too much time that could, in between those things that could cause different things to happen. So really, companies usually predict 1, maybe 2 quarters at a time. That's about it, right? They give projections just 1 or 2 time periods out because there's too many other factors. So when we look at this, what is the scope of this model? Well, our data here starts when X is 0, and our data ends when X is 14. So we would say our scope is like 0 to 14 missed classes, right? The number of absences, because that's where the data is. That's the data that we have. So then we think about, well, what could we estimate? Could you estimate 16 missed classes? You could, answer this either way. I would say yes, because this data is actually, it looks to be pretty linear. It's only 2 time periods away. So I think that would be okay. Anything past 16, I think would be too much. So I think 16 is like the end. This is the most you could estimate out without really having more data to show. Hey, and that's it. So basically with scope, 1 to 2 time periods out is really about as far as you could go.